Hey guys, today we are looking at 5.6, which is all about composite and inverse functions. Yesterday for 5.5, we looked at combining two functions together with our basic operations of addition, subtraction, multiplication, and division. Today we're going to be combining them in a different way called composite functions. A composite function is literally taking one of my functions and inserting it into the other one for my variable. So it's combining them in a way that my one function becomes the input for my first function, and then I combine them together. So format-wise, the way that I would read this, it's example number 1 here for part A. It's kind of an open little circle. It is different than just our dot that represents multiplication. F of g of x. I usually actually write it as like a full O, fog, f of g of x. That's how that is read. Whoops, let me include my x here. That is read as f of g of x. Because you're doing f of g, and that's both of x. So what f of g of x means is, like it says, I'm taking f of g of x for my function. So I'm taking what g of x is and putting it in to f of x for the input. So I'm just going to start with doing our substitutions. We're told here in example number 1 that f of x is 3x minus 4 and g of x is x squared plus 6. So I'm going to go ahead and take that x squared plus 6 and substitute it in for x in my other one. So first layer deep here, we're going to plug x squared plus 6 in for g of x, right? We know x squared plus 6 is g of x. So if that's going into my f of x, it's going to go right in here for the x value of my function, which is g of x. So f of x is 3 times my x value, my input, minus 4. So from here, I just have to simplify. So I'm going to distribute my 3 in there. 3x squared plus 18, and then we still got minus 4. So our final simplification, we'll put it in green here, is 3x squared plus 14. That is what f of g of x is equal to. Now, because f of g of x, we're putting one function into the other, order is super, super important here. F of g of x is very, very different than g of f of x. Where in like the function operations we saw yesterday with addition and multiplication, the order didn't really matter. It's just combining them together with those two operations. Where here, our order does make a big, big difference. Because what I'm asked to do here with g of f of x, I am taking now g of f of x. So now I'm taking g of, we know that f of x is 3x minus 4. G of x is, what I'm asked to do for g is square my input and then add 6. So I'm going to have to do some foiling. I'll probably just do that off to the side over here with some scratch work. You can even do your little box multiplication with 3x minus 4 times 3x minus 4. We get 9x squared. This we get positive 16, negative 12x, negative 12x. So when we add our like terms up here, we end up with 9x squared minus 24x plus 16 plus 6. So my final simplification here in green is going to be 9x squared minus 24x plus 22. And that's what g of f of x is in this case. So go ahead for this next example, for a little checkpoint 1. I want you to go ahead and pause the video real quick and try this next example on your own. Try f of x being 5x plus 6, and g of x being x squared minus 1. And I want you to do both g of f of x and f of g of x. So go ahead and pause the video. And then once you are done with both of those, go ahead and hit play. And I'm going to go through those real quick for you now. So I'm not going to color code it just because it's taking too much time for me to switch back and forth. F of g of x we know is this process. So in this case, g of x is x squared minus 1. So f of x squared minus 1. My function is, my f of x is 5x plus 6. So 5 times x squared minus 1 plus 6, which is 5x squared minus 5 plus 6. So 5x squared minus, or sorry, plus 1. 5x squared plus 1 is what f of g of x is equal to. Moving over to part B, g of f of x. That is g of f of x, which is g of 5x plus 6, which is 5x plus 6 squared plus, minus 1. When I FOIL that, I should end up with 25x squared plus, what do we get? That's 30, so plus 60x plus 36 minus 1. So 25x squared plus 60x plus 35 is g of f of x. And that's composite functions. All right, so our next main idea here is something called inverse functions. Now, we've talked about inverses a ton, more so in Algebra 1, but we still use inverses all the time in here. Inverses just meaning things that undo each other, right? Addition and subtraction are inverses of each other. Multiplication and division, squaring and square rooting something, cubing and cube rooting something are inverses of each other. But two functions can also be the inverses of each other as well. And what that means is that if I were to take one function and compose it with the other and do a function composition, what one function does, the other one undoes. So if I put something into my first function and then put that output back into my other function, it's going to end me back up with what I started with originally. And what that looks like for us, the way that we're going to assess this, is in order for us to be inverses of each other, if I did f of g of x, I'm just left with x. And if I do g of f of x, I'm left with just x, which means that whatever I put into my function, I get that same thing just right back out every single time. Our inverses we usually write in this form. I'm going to circle it in blue. No, I'm going to highlight it in yellow. Boom. It looks like f to the negative first of x, but it's not saying, that's not like x over f, it's not a negative exponent. It's just saying the inverse of f. So first thing we're asked to do is identify if two things are inverses of each other. Again, we're going to check to see if one composed in the other gives me just x, and the other direction also forms the same thing. The way that this is said, before I forget, the way I would say this symbol here, with two different ways. We can say this is f prime of x, or f inverse of x. I'll usually use the f inverse of x just to emphasize that we're an inverse, but f inverse of x, f to the negative first of x is what it looks like, but f inverse of x is how we would say that. So for part A, we're checking to see if f and g are inverses of each other, and then for part B, we're checking to see if h and j are inverses of each other. So the way that we'll do that, I'm going to have to skinny my markers up here a little bit. I'm testing first to see if f of g of x gives me an x back out. So in this case, f of g of x gives me 5 of x over 5. Right, I'm doing g of x is x over 5 in this case, so I'm plugging that in for my x value of of f. Maybe I'll show my steps here. F of g of x is x over 5, so 5 times x over 5 gives me x back out, which is what I want. I want it to be an x on the back end. If I do the other direction, g of f of x gives me g of 5x, which g does my input over 5. Hey, look, those cancel out. So I'm just left with x once again. So I can conclude, yes, f and, well, I'm not going to put plus, f and g are inverses. For part B, doing the same thing here. I'm just checking if h and j are inverses of each other. So we'll go ahead and say, all right, well, is h of j of x x? Well, h of x minus 2 over 3. And we're plugging that in for x in my h function. 3 times x minus 2 over 3 plus 2. Well, order of operations here, my 3's cancel out. I'm left with x minus 2 plus 1, or sorry, plus 2. Hey, look, plus 2 minus 2 cancel each other out. I'm just left with x. So we are good on that side. I have to check the other direction. Is j of h of x the same? Well, j of 3x plus 2, which is 3x plus 2 minus 2 all over 3. So up top, plus 2 minus 2 cancel out. 3x over 3. 3's cancel out. And I'm just left with x. I forgot to switch my color. We're going to hack it. There we go. So, yes, once again, I'm just going to say yes. They are inverses of each other. Once again, I want you to go ahead here at checkpoint 2 and check to see if these functions are inverses of each other. I want you to check and see if this f of x, 4x minus 7, is the inverse with g of x, which is x plus 7 all over 4. It looks like it's going to be. You're just going to have to make sure you check to see if it ends up coming out to be that they are inverses of each other. So go ahead and pause the video again. Check this on your own. Check to see if f of g of x gives me x and g of f of x gives me x. Okay, now that you've gone through and done that, let's take a look at it together. I'm going to go ahead and test f of g of x first. So that's f of x plus 7 all over 4, which is 4 times x plus 7 all over 4 minus 7. My 4's cancel out. I'm given x plus 7 minus 7. Those two cancel, and I'm just left with x, which is what I want. Yay. Sweet. All right, other direction again. G of f of x gives me g of 4x minus 7, which is 4x minus 7 plus 7 all over 4. Minus 7 plus 7 cancel each other out. 4x over 4. My 4's cancel, and I'm left with x. So once again here, yes, inverses. Yay. All right, last one. Last new skill. So a lot of the time, we're not going to be given the two functions. We're not necessarily just checking to see if two things are inverses of each other. We're going to be given a function, and we're just asked to find what the inverse would be. Which, the way that we do this is a pretty simple process. We're trying to, because of what an inverse is, we're trying to find the thing that undoes what's happening to my x value. Right? If I'm looking at these two examples, f of x was taking my x value and multiplying by 4 and then subtracting 7, which means my inverse has to be the opposite of those two things. It has to divide by 4 and add 7, which, again, that makes sense. That's why those two are inverses of each other. What I have to be careful of is that we're doing it in the correct order, which is why we have this process set up. What we're going to be doing is taking my function, taking f of x and first replacing it with my y value. So we've got just a single thing to worry about. And then I'm going to flip-flop x and y in the equation. So I'm literally just going to not change any values. I'm just going to take x and y and switch their positions. And then I solve for y again. Because what's going to happen then is all the things that happen to y, I'm going to be undoing them, but in the correct order. That will give me what my function inverse is. So for example number 3 here, if we're trying to find the inverse of f of x, which is 7x minus 5. Step number 1 is to replace my f of x with a y value. So y equals 7x minus 5. Step 2, I'm going to switch my positions. My x and my y get flip-flopped. So now it's going to be x equals 7y minus 5. And then I just go through and solve for my y value. So here I've got to add 5 on both sides. X plus 5 equals 7y. Divide by 7 on both sides. So I get y equals x plus 5 all over 7. Simple last step. You're just replacing your y and putting in your f inverse of x symbol, because now we know that this is the inverse. So f inverse of x is x plus 5 all over 7. That is the function that undoes 7x minus 5. So for our very last checkpoint number 3, go ahead and try this one on your own. I want you to find the inverse of f of x equals 2x plus 7. 2x plus 7. And pause the video, do that problem on your own real quick to test your ability, and then go ahead and hit play once you're ready to check your answer. Okay, so once again, first step, f of x, replace it with y, 2x plus 7. Step 2, flip-flop x and y, x equals 2y plus 7. Step 3, solve for y. Here I'm going to subtract 7 on both sides. X minus 7 equals 2y, because those two cancel out. Divide by 2 on both sides. Y equals x minus 7 all over 2. Step 4, whatever it is, I think step 4, go ahead and write it in function inverse notation. X minus 7 all over 2. Yay! Not so bad. Not so bad at all. All right. So your homework is up there on the screen, page 281, 6 through 20, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Have a fantastic day. We'll see you soon.